Hello everyone. Today we will discuss about some diagrams. Here in the first diagram we have seen that this is the 82C55 processor in which we have the data input from D0 to D7, port A from 0 to 7, port B from 0 to 7, and port C lowercase, which is connected with B, is from PC0 to 3, and the port C4 to port C7, which is the uppercase, is connected with A. We can describe it with the color. The group B is in the purple color and the group A is in the green color. So port A and uppercase of port C are in the group A, and group B conducts of port B and the lowercase of port C. Here is the read function, write function, address, reset, control select, and VCC and ground. Here we have in the address section 00 is to select the port A, 1 is to port B, 2 is to port C, and 11 which is command register. This is the diagram of grouping in 82C55. Moving to the next. This is the diagram of 8086 IO, where in the 82C55 processor we have port A, port B, and port C. Here you can see that port A is CH0, in port B you have C2H, and port C you have C4H, which is the command register is for C6H. This is the hexadecimal codes. Now here we have a control select which is connected with some added address ports. Those generate a control signal which is CH and active low, and here it is connected with reset, address, read and write, active low, and the data section which is from D0 to D7. In the bottom we have VCC and the ground. This is the port address section diagram. Now moving to the next. Now we are in the command byte 8. In program's path A, B, and C, we conduct from 0 to 7 if there are two groups, group B and group A. We can select the group A, which is the port C from P7 to P4, which is connected with the destination of 3, and 1 is for input and 0 is for output. In port A we are connected with the port number 4, and 5 and 6 number port is connected for mode selections. Here we have three modes: mode 0, mode 1, and mode 2. In the last one is 7 number position is 1. If this is 1, so this can generate the command byte, which is the red signal for group A and group B. This red color indicates that if the last position is 1, it will go to the command byte port, and if the last 7 number port is 0, then it will go to the command byte B, which is where we can say that 6, 5, and 4 is don't, and then 0 is for bit selection, where it is set, it can be set or reset. 1 is for set and 0 is for reset. In 3, 2 and 1 is for select bit, and 4, 5, and 6 are don't care. So listen carefully that 7 number position, if it is 1, then the command byte A is selected, which are the group parts, and if the 7 number position is 0, then the command byte B is selected, which is known as BSR. Now we can see the diagram of 8-digit 7-segment LED display interfacing. This one is very important for your exam question point of view. Here we have port A to port 7, which is connected with the ground, and finally connected as a column section, and the port B to B7 are connected with the rows, where port B to B7 are connected with the column section with continuous 8-digit 7-segment display, and the port A to A7 is connected with the row segment, and the C0 to C7, which is port C, is not connected. Here we have a chip selection, a reset, a read, write and address function, and here comes the data section. This is the diagram of continuous 8 7 segment display. Here we have 3 3 and 2, that means which is 8 number of 7 segment display to display the continuous number of 8 digits with the 7 segment display. Now have a snap of this because this diagram is very important for your exam question. Moving to the next, here is the 4 into 4 keyboard matrix interfacing. This one is also a very important thing. Here you can see that the row wise the A is working, where the from A port to A7 are available, but we are using from A0 to A3 for 4 rows, which are the row section, and each of section we have a switch. Now this one is a switch, this one is a switch, this one is a switch, and this one is a switch. Again we have this one is a switch, this is a switch, and this is a switch. So it have 4 times 4 matrix. That's why this is called 4 times 4 keyboard matrix interface. We have data section, read write, address, reset, control, and C is doing nothing here. Now we are in the port B, which is connected with the column section from B0 to B3 for column 1, column 2, column 3 and column 0. Here we have conducted with the VCC. If you press this button, then the row 0 and column 3 are connected. That's how the switch works, and that is the figure of 4 times 4 keyboard matrix interfacing. This one is also a very important diagram for exam questions. Have a snap of this one. Now moving to the next. This one is the flow chart of keyboard scanning procedure. Here first of all we go to the key section, then we will go to the scan key section, then time delay for debounce, then we will go to the scan key, then to the check section. If the key is closed, then we will turn it into the scan section again, and if it is not closed, then we will send to the next portion. This red portion is for wait for release, and this blue portion is for wait for key store. In this section, firstly we will go to the scan key, then the time delay, then again the scan key, then the check function. If the key is open, then we send it again to the scan key, and if it is closed, then we send to the calculate key code. Then it will return as a result. So this is how the flowchart of keyboard scanning procedure works. This diagram is also important for your exam question. Please have a snap of this one. Now moving to the next. Here are some description of STB, IFB, INTR, INTE and P0, P7. This IFB is for input buffer full, and INTR is for interruption request, and the next one is interruption enable. From this name of this task you can easily know what is going to do. Now have a snap of this one. In here we have a diagram for mode 1 and port A, mode 1 in port B. In this diagram we have first a STB which is active low to active this section, and then the STB is connected with PC4 and PC5 is connected with IFB. Then it will generate an INTR, which is interrupt request is generated by this section, and when the interrupt request occurs, then it will go to the port B section where there is a read low function, and the read low function works. Then it will generate a STB to the port 2, and port 1 is connected with IBF, which is buffer full. Then if the buffer full, it will generate an request which is INTR. Have a snap of this one. This is a simple diagram. Another things to know, you have ACK is for the acknowledgement, and now OBF is for output buffer full. Here we have the diagram again with the acknowledgement section, because instead of STB we have used here acknowledgement. First of all, we generate a write section, then get the P6 port with the acknowledgement, then P7 generates the output buffer full, then PC3 generates the request. In the port B section, first port 2 is connected with the acknowledgement, and port C1 is from the object buffer full, and port C0 generates the interruption request. Here are some other stuff which you need to know. Just go through them for once. Those are not very much important, but not less important also. This diagram is for acknowledgement and STB in the same diagram. This is also an important diagram. Have a snap of this one. That's for today. These diagrams are very important for your exam question, so please have a snap of those diagrams and practice them for your examinations. No more today. Thank you.